Okay, we have one last day of dealing with trig identities and trig formula ideas. These are 8 formulas. Once again, we're not going to go through the derivation of them. I'm just giving them to you that we can use. They're called sums to products formulas. Okay, when you're dealing with sums and products formulas, when you're dealing with sums, you're dealing with addition of things. When you're dealing with products, you're dealing with multiplication of items. So what you're looking at here is you're looking at how we can change things from addition to things that are multiplication. Because things that are multiplication tends to help us out mathematically being able to solve equations. Because I can utilize what is called the multiplication property of 0 to be able to solve problems. So when it's in an addition form, it's tough to solve. But it's in a multiplication form, it's easier for me to solve an equation. Sort of like what you have with a quadratic equation. If it's in this form, x squared plus 2x minus 3 is equal to 0, and I ask you to solve that equation algebraically, we can't just add 3 to both sides and divide by a coefficient because we have an x squared and an x term. So in this form, we can't multiply or we can't solve the equation. But if I take the form x plus 3, bless you, and x minus 1 is equal to 0, if I put it into a multiplication form, I can then solve the equation. But in the addition form, I can't solve the equation. I said that x could equal -3 and x could equal 1. I can solve the equation at that point. But in the addition form, in this form right here, we don't have techniques to be able to solve the equation. So it's beneficial sometimes to take it out of the addition form and move it into a multiplication form. Well, there's 8 sums to products or products to sums equations that we can come up with. And these are all provided for you. These are all things that you should, once again, these are the last 8 things that you add to your list. What you will be asked to do is you'll be asked to prove one of these first 4. Okay, one of these first 4. Well, we're going to take a look at the first one right now. And it's not a difficult proof of an identity. We have the sine of a plus b plus the sine of a minus b is equal to 2 times the sine of a times the cosine of b. Well, how we prove this is let's take our first 2 quantities on the left-hand side and let's use our angle addition formulas and expand them out, or subtraction formulas. What would it look like if I had the sine of a plus b? What would it look like if I had the sine of a minus b? So expand it out using your sine of 2 angles being added, 2 angles being subtracted. Bless you. Sine of a plus b should have sine of a cosine of b plus the cosine of a times the sine of b. And then we're adding to this the sine of a minus b, which is sine a cosine b minus cosine a times the sine of b. So all we're doing is we're using our angle addition formulas to expand them out. Now, if we look at what we have here of our 4 terms, we have 4 terms. Sine A cosine B, cosine A sine B, plus sine A cosine B, minus cosine A sine B. If I would look to combine my like terms, a like terms means everything has to be identical. Well, if I take a look at things that are identical, if I look at cosine A sine B here, and a minus cosine A sine B here, what happens to those two? They cancel out. These go away. Why? Because I have one plus and one minus. Let's take a look at my other two terms. I have sine A cosine B plus another sine A cosine B, which gives me how many of them? Two of them. And that's what we're trying to get to. We is done. They're not difficult proofs, identities to prove. I will give you one of these first four to prove. And all it will be for you to do is expand out sine of A plus B minus the sine of A minus B, or cosine A plus B, cosine A minus B. Expand them out. You're going to be able to cancel two of the terms. You're going to be able to add two of the terms together. Okay, so it will be a very, shouldn't be a difficult identity for you to prove. These here are probably a little bit more practical in solving equations. If I have the sine of two angles being added together, I cannot combine these together. Okay, I can't combine sine of x plus sine of y to say this is sine of x plus y. I don't have a distributive property of trigonometry that I can utilize. But if I have two angles that are separate that are being added together, I can combine them together. By taking 2 times the sine of the two angles added divided by 2 times the cosine of the two angles being subtracted divided by 2. So it allows me to combine these two together and make them into a multiplication form. Why is that useful? Just like up here, in the addition form, we're not capable to solve equations. When I move it into a multiplication form, I can solve this equation then. X equals -3 and x equals 1. But I would not be able to do that in this form up here. So changing, once again, things to multiplication allows me to be able to solve equations. Question? Now, if we take a look at the characteristics of what we have here, we have equal signs in all of these. If I take a look at the equal signs for all these, on the left-hand side of these equal signs, we have sums and differences, which means we have additions and subtractions. On the right-hand side, what we have on the right-hand side is we have products, which means we have multiplication. Yes and no, we divide by 2 and a couple of them down there. But for the most part, everything is turned into multiplication. And once again, when we have things in multiplication form, it allows us to be able to solve equations. Once again, these are 8 things that you should add to your trig identity sheets. Take a look at some problems. We have the sine of 5 theta minus the sine of 3 theta is equal to 0. And we want to solve for the general formulas for theta. Well, we cannot combine these together. We can't say this is the sine of 2 theta and be able to solve the equation. But what we can do is utilize the front-hand side to be able to determine or rewrite our equation and take it out of the addition subtraction form and put it into a multiplication form. So what I want to take a look at is on the left, on the back, on the front side. Do I have the sine of something minus the sine of a second thing. Yeah. We have the sine of x minus the sine of y. And when we have the sine of x minus the sine of y, and to be quite honest, I don't memorize these. These are the ones that, as you know, I've taught this for like 87 years. I'm old. These, all those other ones, half angle, double angles, all that other stuff, I can rattle them off. These here, no, I don't. I don't know these. I still have to look at these every year. Okay, so I look down here, I see the sine of x minus sine of y is equal to 2 times the cosine of x plus y divided by 2 times the sine of x minus y divided by 2. Okay, should be third one from the bottom. So all I'm doing is I'm looking to see which one do I have on the left-hand side. Well, my x is 5 theta, my y is 3 theta. Here's my x and here's my y. So we're left with 2 times the cosine of 5 theta plus 3 theta divided by 2 times the sine of 5 theta minus 3 theta divided by 2. And this is equal to 0. Once again, just going back to this. In this form, I can't solve this equation. I don't have techniques of solving this equation. X squared plus 2x minus 3. Because I'm adding these terms together. But when I change it to multiplication, I can now solve the equation. In this form, I have no techniques to be able to solve this equation. But when I change it to multiplication, I now have techniques to be able to solve the equation. Once again, that's that multiplication property of 0. The multiplication property of 0. If I have things being multiplied together to equal 0, one of those things has to equal 0. One of those things has to equal 0. If I have things being multiplied to equal 0, one of those things must equal 0. Well, what I've done is I don't have an addition property 0, but I've changed it to multiplication and I'm equal to 0. So I'm multiplying these things together to equal 0. So one of those things must equal 0. Well, I have 5 theta plus 3 theta, dividing that by 2. What do we get? 5 theta plus 3 theta divided by 2, Grace. What would that be? What's 5 theta plus 3 theta? 8 theta divided by 2. Cosine 4 theta times 5 theta minus 3 theta divided by 2 gives us what, Sophia? 1 theta or just theta? We have 1 theta or just theta is equal to 0. So utilizing the multiplication property of 0, one of these things must equal 0. Well, we could say 2 is equal to 0. Cosine of 4 theta can equal 0, or the sine of theta can equal 0. Well, can 2 ever equal 0? That gives me an empty set. If you say, yeah, 2 can equal 0, then okay, you give me $2, I give you $0. We call it even. Cosine 4 theta is equal to 0. We need to solve the equation. We have cosine there. Next, what we're going to do? Huh? How are we going to solve it? What should we do? How do we get the cosine to the other side?
Opposite cosine.
Inverse cosine. Inverse cosine. So we have 4 theta is equal to inverse cosine of 0. Clickety clack, clickety clack. 90. But we took the inverse cosine. So we have to take a second value. What's the second value? Inverse cosine? Opposite. So we have negative 90. We can divide through by 4, by 4, by 4, by 4. So we have 90 divided by 4, 22.5, or theta is equal to negative 22.5, plus or minus the period n. What's the period here? Here's our b value. Period would equal what? 90. N. Sine theta is equal to 0. Okay, so what are we going to do to get rid of the sine? Inverse sine. So we have theta is equal to inverse sine of 0. Zero. Or second value, 180 supplement. Plus or minus the period n, or our b value now is 1, so we have plus or minus 360 n. So we have 4 general solutions here. 4 general solutions that will give us values that would work for this. Once again, in this form we can't solve it. Get in a multiplication form, we can now solve it. Rewrite as a sum or difference of sine and cosines of positive values. We are now in multiplication. We want to now write it as a sum or a difference. So if we're looking at, we're starting out as multiplication, which is the right-hand side of the equal signs. We're looking to see, do we have 2 times the sine of an angle times the cosine of another angle? Do we have 2 sine of something, cosine of something on the right-hand side? Do you ever find it? It's the first one, isn't it? First one. On the right-hand side of the first one, we have 2 sine A, cosine B, which is, here's our A, here's your B. And we want to take it and move it back to the left-hand side to make it a sum and difference. So we have the sine of A plus B, and we have the sine of A minus B. Just throw in your A and B. We have sine of 40 plus 60, sine of 40 minus 60. So we have sine of 100 plus the sine of negative 20. Okay, not a difficult process here, except for we have to make sure we satisfy the instructions. We want to make these a positive angles. The problem we run into is we have negative 20 there. we want to make this a positive angle. Well, how do we make angles? Well, how do we deal with the angles that are positive and negative here? We want to switch them and change some things around. Well, it goes back to what we talked about in the last section, odd and even functions. For the cosine was an even function, which means the sine, the cosine of 30 is equal to cosine of negative 30. Okay, if it's even, I'm putting in opposites, I'm getting equal values. That's what it means to be an even function. So if I have the cosine of any angle that is a negative value. If I have the cosine of negative 70, I want to make this positive angle, I could just use my eraser postulate and say that's equal to cosine of 70. So the cosine of negative x is equal to cosine of x. We can just drop a negative sign for any cosine there. If I have cosine of negative 150 degrees, I could drop the negative sign. That's equal to cosine of 150 degrees. The cosine of negative 1,000 equals the cosine of 1,000. The sine is odd. The sine is odd, which means opposites will give you opposites. The sine of 30, or sine of negative 30, is equal to the negative sine of 30. Opposites give you opposites. What that means for us, if I want to write equalities, the sine of negative x is equal to negative sine of x. So basically what happens is this negative sign will get thrown out front. If I have the sine of negative 30, this is equal to negative sine of 30. If I take the sine of negative 30 and take the sine of 30, they come into opposite values. Well, if I put a negative here to get my equality, I can satisfy my equality by putting a negative out front. So when I'm dealing with a negative sign here in the sine, it's going to come out front. When I have negative with the cosine, I can just erase it. So this negative sign here will get thrown out front. So I have the sine of 100 plus the negative sine of 20, or I can write that as sine of 100 minus sine of 20. And that's how you create a positive angle there. We are now dealing with addition. We want to rewrite this as, rewrite the sum as a product. So we are in addition form, we want to write it as a multiplication form. So just take a look on the left-hand side, because we're dealing with addition. How do we change that to multiplication? So you're looking for, do you have a cosine of something plus the cosine of a second? So second one from the bottom. You have cosine x plus cosine y. 2 cosine x plus y times cosine x minus y. So we have 30 plus 80 divided by 2 times the cosine of 30 minus 80 divided by 2. Just plugging in for your x and your y. So calculating our values here, 30 plus 80 divided by 2, Kano, gives us what? What's this give us? 55 times the cosine of 30 minus 50, 80 divided by 2 gives us what? Negative 25. So we write it as products, but we need to make sure that they're positive angles. Now we have a cosine of a negative. We have a cosine of a negative. Cosine is even. So what can we do with our negative sign? Just drop it. So this is 2 times the cosine of 55 times the cosine of 25. Just drop the negative sign. Homework. We have on page 144, 145, 3 to 39. Okay, 3 to 39. Now, if we take a look at these, we have 144, 145. Okay. Problems 1 through 12 are these problems right here. Problems 1 to 12. Problems 13 to 24 are these problems here. And then problem number 27 is this problem here. You can stop at 27. You can stop at 27. I set up 39 there. You can stop at 27. You won't have to worry. Once you go below that, I'm proving some identities. You don't have to worry about proving the identities. Sorry to disappoint. I'm really sorry. I know it's probably going to ruin your week now. All right, this will be the last of the material. Monday, when we come back from break, you're going to have a couple worksheets that's going to review double angles, half angles, and some of the product formulas. We'll do that on Monday and Tuesday. Wednesday will be a review day. Thursday will be a test over the last half year. Questions? All right, QD is done.
I do have one question.